Okay, so
This is for which chapter?
chapter 8. Right, chapter 8 to chapter 7. Chapter 8 will go pretty fast to get together. So, chapter 8. We're working in an hour. So chapter 8 to chapter 7.
You should, I have it. So heavy.
So last week, you guys looked at chemical reactions. So what were some of the evidence that a chemical reaction has occurred? Color change. It was irreversible. Was that evidence that it?
It's probably.
Well, yeah, I have mentioned it before. Color change. Give me some other things, some other evidence.
The heat change. Or
So
the temperature change.
temperature change, heat emission.
So this,
What was that?
like I'm not sure if I'm saying it right.
So the change in viscosity.
Yeah.
So, okay, change in viscosity. Okay. Anything else?
Integration of ashes.
Okay, decomposition. Okay. Anything else? Those are types of reactions. Evidence of that. This one. Okay, so what else did you guys see? You guys see
One thing went whoosh.
one thing with whoosh?
Yeah, like it looked like, you know, when like something, like, okay, when a building's on fire and then all of a sudden it goes whoosh, and it's like white flames go everywhere and stuff, like
So
not
you
flames,
got
but like ash,
flames?
not
You got
flame,
ash?
ash.
Ash,
Yeah.
okay. So
Something
you
like
got
whoosh.
solid formation? Okay. Okay, did you guys get any bubbling?
Yeah,
Oh,
something
this-
bubbled.
Okay, okay, so evidence of chemical changes, we see chemical changes all the time, right? So you guys told me, you said color changes, you said solid formation, you said gas formation, you had the absorption and the release of heat energy, you've had light emissions. So an example of color change, this is permanganate, as it ionizes, it goes up to its ion components, it will actually change to a lighter pink, purple color. Okay. Sometimes when we add two of this together, we get solid formation. You guys did a lot of that. You got a lot of precipitants. You got that yellow color that came out, right? Let it sit, it'll actually start falling down to the bottom, and then you'll get separation of the liquid and the solid at the bottom. You guys saw the gas formation. So when you guys add the magnesium to the hydrochloric acid, we saw bubbles coming up, right? And so that means that we have hydrogen that was being released. You guys felt tubes that got a little bit hot. You guys feel the one with the magnesium and the water, right? So that one got pretty warm. We also can look at light emissions. So if it was a combustible reaction or combustion, we basically get light formation from the fire that comes out. Or in the case of the glow stick, you break open a glow stick, right? You get glow. So there's also heat transfer. Heat transfer is a form of a chemical reaction. It could be a form of physical reaction, but more than likely it's a form of chemical reaction. So if you take, for instance, you guys ever been to water? And those means this ice pack. And you pack with ice packs or anything like that, or like spray ankle or something like that, maybe ice pack. Okay, so that ice pack, right, is made up of ammonium nitrate and water. And so as soon as you crack open the crack open the pack, the water flows in, and then it starts cooling, right? Because it's absorbing all of the energy from the outside. What was that?
There's one that gets
Warm,
warm.
yes, exactly. So it works just the opposite. It's a different set of chemicals. And so in that case, you get exposure to water, and then energy is going to be released as a result of it. So it gets warm. Okay, so in this chapter, we're going to be talking about balancing chemical equation, but you guys already know how to do that, right? So this, a lot of it is going to be a review. So we should go through it pretty fast. Now, the part of it that I want to focus on is actually that nomenclature. Nomenclature, you sit there and determine what the chemical equation is, and then also predict what the products are. Okay. So if we take a look at this reaction, we have sodium reacting with water. So we have solid sodium. It's going to be added to liquid water. So how would I write that in a chemical form? Okay. Okay, sounds good. Gotta be confident. Plus H2O, right? So it's Na. And we know it's a solid, right? Because they told us it was a solid. So how do I represent solid? And you said plus H2O. Okay. And what are we going to get? What are going to be the products? So it says, when sodium, solid sodium is added to liquid water, a reaction occurs, producing hydrogen gas, sodium hydroxide, and heat. So what do we know about hydrogen gas? It's a special group. It's called the 7. Diatomic, so I would write it as H2. Okay. So solid, liquid, or gas? And it says sodium hydroxide solution. What does that mean? OH. Okay. And solution. How do I represent solution? So anytime that you see the word solution, you should associate it with water, right? So there's that. A liquid. AQ. Or aqueous. Okay. So is that balanced? No. Okay, what do I need to do to balance it? So I have, how many sodiums do I have on both sides? 1 on each side. Okay. How many oxygens do I have? 2 oxygens. 2? I have 1 on each side. Okay, 1 oxygen on each side. And then how many hydrogens? I have 2 on one side, and 3 on the other. Okay, is that balanced? Okay, what do I need to do to balance it? I put a 2 here. Okay, so that would give me how many hydrogens? altogether? That would give me 6. That would give me 4, because I have 2 here, and then I have 2 here, so that'll be a total. Okay, that will give me how many sodiums? 2. And then that would give me how many oxygens? Reactants. Okay. So then that would give me 2. 2. And that would be 4. So that's balanced, right? Okay, so that would be a balanced chemical equation.
Are we balancing more?
Yeah, you're going to be balancing more, but the balancing part of it is just part of it. The important part of it is using nomenclature to get to the test. So you saw how you guys pieced together all the components. That's what we need to work. Okay, so the states, as I had mentioned to you earlier, S is for solid, liquid is for liquid, L is for liquid, G is for gas, and AQ is for aqueous, which basically means it's dissolved in water. So anytime that you see a solution, it's making reference to it be aqueous. Okay. Is that good? Okay, so the do's and don'ts to balancing chemical equations, you guys know this already. So the first thing, do's, you want to make sure that you're using coefficients on the correct chemical formulas. Right? If your chemical formula is incorrect, if you have the wrong nomenclature, then it's going to make everything wrong. Right? So it's important for us to remember our diatomics. Who are the diatomics?
Iodine.
Helium. You should know this at this point.
I don't remember if it's helium.
It's not helium.
It's hydrogen.
Hydrogen. We just talked about that.
Then it's iodine, chlorine, bromine. And then here, nitrogen, oxygen, and
Cl.
chlorine.
Okay. Again, have no fear of ice cold beer, and it's not helium. Okay. Okay, so we want to make sure that we know that, right? We also know that sulfur is 8, right? And phosphorus is 4. So don't. So you don't want to change the chemical formula. The chemical formula tells us what it is. So once you get the right chemical formula, that's good to go. You want to use coefficients, right, to balance out the chemical equations. You don't want to change the chemical formula. You don't want to make up shit, right? It has to be, what was that? No, coefficient is the number that's in front, the big number, right? Okay. So you want to make sure that you're not making things up, right? You don't want to make up a new chemical formula or a new chemical compound, or just use the real ones that exist and just, okay, I'm just going to add another H here because, you know, I'm supposed to have another H, you know? You don't want to do that, okay? So you need to make sure what you have. The other thing that we need to pay attention to is the type of reactions. What are the 4 types of reactions that we know? Talked about it. What was that? Decomposition.
Or replacement reaction.
Single replacement.
Synthesis.
And then
Synthesis.
double replacement reaction.
Double replacement. So those are your 4, right? Your 4 major one. I told you that. We also talked about combustion. Okay. So we want to sit there and make sure that we're balancing both sides of the equation. Put in, we've got to get out. Okay. So we've already done this one. We're not gonna worry about that one. Let's start off with this one. Balance the equation for the reaction of a solid phosphorus pentachloride with liquid water, yielding aqueous solutions of phosphoric acid and hydrochloric acid. So what are my reactants? Give me one of my reactants for you. Read the question. I'll read it out loud again. Listen to what I'm saying. Don't give up on it, okay? So it says balance the equation for the reaction of, so that tells me right there, those guys are doing what? They're reacting, okay, of solid phosphorus pentachloride with liquid water. One of my reactants. Okay, solid phosphorus pentachloride. So phosphorus, what is the chemical symbol for phosphorus? pH, nope,
P.
it's just P. Okay. And pentachloride. Penta means what? So we have 5 chloride. And then there's, it's a solid, right? So what symbol do I use for solid? Okay. Okay, Rick, what is it reacting with? What is it reacting? Water. Okay, so it's chemical symbol for water. H2O. And then to represent liquid, what am I going to use? Okay. What are the products
Of what?
of this reaction?
Just read
It's
it
gonna
like
be an
how it's
acid.
supposed to be written, or read the word.
It says yielding aqueous solutions of phosphoric acid and hydrochloric acid. So my products are going to be
Wait. Yeah, hydrogen.
Are you sure? It says yielding. Yielding basically means arrow make equals what it is on the other side. That's what yield. What was that? Phosphoric acid. What is the chemical symbol for phosphoric acid? It's H3. PO1. PO4. PO4. And then 18. And what is the other acid?
Hydrochloric. No.
Hydrochloric.
Hydrochloric.
Hydrochloric. Okay, hydrochloric.
Close-ish.
Okay, chemical symbol for hydrochloric.
HC. Big H, big C, and then like a little L.
Okay. And to represent that acid part of it.
Aqueous in parentheses.
Okay. Okay, is that balanced? No. How do I balance it? How many phosphorus do I have? On both sides. Okay, how many hydrogens do I have? I have 2 on my reactant side.
4 on your other side.
Or on my product side? How many oxygens do I have?
One.
I have 4 on my product side and on my reactant side. Okay, is that balanced? Okay, what do I need to do to balance it?
And 2 in front of the hydrogen.
Here,
Yes.
so 2 in front of the water. So that means we have 4. And we have, are you sure? That's 2
I'm sorry,
times
2.
1. 2.
Wait, so then it would be a 4 in front of the hydrogen instead?
Okay,
Wait,
No, because
Never
they're
mind.
gonna change it.
so you're saying. what-
No, then
what
that would make
about
it
the chlorine?
Oh, but then
Oh, I
when
forgot
you
the
multiply
chlorine, it
times,
doesn't tell me.
oh, it's gonna be a 2.
So I have 5 and 1, right? So I need to put, you're saying, put 4 in front of the water,
Well, you can, but then you have to change it on the other side.
okay?
yes.
So if I put 4 in front of the water, I have 4 oxygens,
And then
and then I have 8
8.
hydrogens, right? Okay. And what about my chlorine? How am I gonna get the chlorine balanced that I forgot about earlier? So if I have 5 on this side, what do I need to put in front of here? So I have 5. Okay, so then that would give me a total of, how many hydrogens do I have altogether?
8.
So is that balanced?
Yes.
Okay. Piece of cake?
Yeah.
Okay.
Oh, you said don't change the sign. Go back. My bad.
Thank you.
Okay, so when we talk about interpreting what the chemical equation means, right? It basically tells us at a particular levels that if we have 2 molecules of hydrogen, we need 1 molecule of oxygen to make 2 molecules of water. Right? If we're talking about on a molar level, we can get away with using that half. We can say if we have 1 mole of hydrogen, we could have 1/2 a mole of oxygen to make 1 mole. This is just basically showing us that, right? 2 molecules of hydrogen, then need 1 molecule of oxygen to make 2 molecules of water.
So mole is the weight of
No, mole is quantity. So, you guys know what it does, right?
Well,
12. Okay. So, a dozen is 12, right? So I could have a dozen of shoes. Can I have a dozen of shoes? Can I have a dozen of donuts? Can I have a dozen of girlfriends?
If you hide it very well.
I mean, it's encouraged to be like everyone on the same page, but you could probably still do it.
Okay.
You're just gonna be very broke and very busy.
Okay. So a dozen can refer to anything, right? Okay, now the term mole, M-O-L-E,
Like a little animal.
like the little, it's spelled exactly like the little animal, but it's not the little animal. The mole,
There's animals.
the mole
If they're not
is
that cute.
gonna be equal to 6.00 times 6.022, sorry, 022 times 10
Only goes
10 to the 23rd power.
It probably will be.
Okay, so 1 mole is equal to 6.022 times 10 to the 23rd power. Okay,
Go to the 23rd.
that's right. So a mole is kind of like a dozen. Only thing it makes reference to that specific number. Okay. And we'll talk, like I said, we'll talk about more about that back to chapter 7. But yes,
So like a mole of donuts.
a mole, yes, we could have a mole of donuts. Or I could have a mole of girlfriends, or a mole of boyfriends, or a mole of both, right? So I could have a mole of just about it, right? It still makes reference to a quantity, right? Okay? You guys good with that? We'll talk more about it, like I said, here in a minute. Okay, so you guys are already aware of how to balance chemical equations, right? We don't need to go over that. Okay, so let's talk about those different reactions. So I gave you guys this example on Thursday. So if we have A plus B,
Thursday,
Wednesday,
lab day.
yeah, lab day. A plus B is, A plus X is gonna yield AX, and that's a synthesis or a combination reaction. Okay, an example. Yes, sir.
What is the arrow mean again?
It means yields or equals or makes or produces.
Or equals?
Yes, well, not quite equals.
Yes, yeah, that's what I was thinking. Because if I put equals, I knew I got it wrong.
Yes, because I would mark it wrong.
And yields, I was like,
Yes.
stop. I was like, no, right.
Yes,
So-
yields. Well, it's not the yield sign.
Yeah.
Yield, because you yield
Okay.
something, you make something. That's what yield actually means, right? Although it's been adopted for the yield sign.
Yeah.
Okay, write the equation for a combination of solid aluminum and gaseous oxygen or solid aluminum oxide. So what is the chemical symbol for solid aluminum?
Yeah.
And then how do I represent it being solid? And what is the symbol for gaseous oxygen? That's right. And then that's going to make
Yes.
is that balanced? How do I balance it?
Start writing them in the middle. Say four.
I can.
Put a 4 in front of the aluminum,
4.
put a 3 next to that oxygen, and put a 2 next to the reaction site.
Product side. Okay, so then that would give me 4, 4, 6. The yield always points to the product side. The yield arrow always points to the product side. Okay. Okay, so we have AX yields A plus X. So this is an example of a decomposition reaction. So we're breaking down to two products. Okay, so an example of this is water decomposing into its elements when electrical energy is added. So let's write the chemical equation for that. So water decomposing into its elements. Okay,
H.
is it balanced? Is there also anything else I need to add? What do we know? What are the states of H2? So you said, no, it's not balanced. Okay, what do I need to do to balance it?
Add two.
In front of what? H2O?
But then it's gonna change. So you gotta add it to the other side too.
Okay, so that's 4.
And now it's full. And now it's full.
Okay,
That's easy. Don't stress me.
okay. So water decomposing and then also coming back together to form water, that's a reversible reaction. So now we're going to start introducing to you guys reversible reactions or reactions that are interrelated. So that means that they're able to go in both directions. Okay, so
How do you reverse like a reaction of water though? Because if you boil so much that it evaporates, you can't even get it back.
well, if you collect the gases, right? Collect the gas. like
Oh.
or
Oh, like the steam and stuff.
So in other words, so in this case, we would have to make this happen, we use energy, right? We have to put energy in to make that happen. In this case, we have to take energy out. To make it happen. Okay. Okay, so if we have A replacing B in the reaction, we end up with AX plus B. Now, I like calling this one, replace the old girlfriend with the new girlfriend. Right? Now, the key is that if A is a metal, and it has to replace the metal that's in the complex or replace hydrogen that's in the complex. Okay. If it's a non-metal, if A is a non-metal, it has to replace a non-metal. Okay,
So if it's a metal, it has to replace metal.
that's right. And if it's a non-metal, it has to replace a non-metal. So copper reacts with a solution of silver nitrate, right? A chemical equation for the reaction. Or my products, I mean my reactants. Cu,
And
silver nitrate,
and
that's nitrate, Ag, okay. Ag, okay. Copper, is copper a solid, liquid, or gas? It's a solid. And the silver nitrate, what do we know about the silver nitrate? Okay, we know the type of reaction that we're gonna have here. What type of reaction is this? What type of reaction? There's only 4 types of reaction. A single replacement. So who's gonna be replacing whom?
So,
The copper is gonna be replacing the silver. Okay, so when we're changing out copper, copper becomes 2 plus. So copper becomes 2 plus, how many nitrates must be with it? There's the charge of the nitrate. What was that?
sure.
-1, right? Where can I find that out at? Where should I look at to find that out at? My polyatomic ion table, okay? So my polyatomic ion table says that it's the nitrogen. Negative, a single negative. So then I'll need, I have copper 2, gonna be Cu, NO3. I'll need 2 of them. It's gonna be equals. Yes,
So why did we do that?
because it's replacing it. You just told me that we're doing a single replacement reaction. So what do you mean by why are we?
I got a little confused.
And what is gonna be the other product? Solid, liquid, gas, or liquids. Is it balanced? No. What do I need to do to balance? Which one? This one? Okay. So then that would give me 2 nitrates, 2 silvers. What else do I need to do? Okay. Here's the balance now. 1 copper, 2 nitrates, 2 nitrates, 2 silvers, 2 silvers. So we have a double replacement reaction. A double replacement reaction is where we're going to replace 2 characters, or we're going to switch partners. A is going to hook up with Y, and B is going to hook up with X. Okay, so usually in this process, we either get the formation of a precipitant, a solid, or we can get the formation of a gas or a liquid. In the other case, we'll end up getting ions. So typically, a double replacement reaction is going to require 2 sets of ionic compounds that are coming together. Right? So switching partners. Okay. Silver chloride precipitates when solutions of sodium chloride and silver nitrate are combined. Right? The chemical equation for the reaction. So what are my reactants? Bill? Okay, so anytime, let me give you guys a little bit of a hint that there's no sodium. Oh, you're talking about the sodium chloride.
Yeah.
Okay, so so silver chloride precipitates. That term right there, that basically means that it's gonna be a product. So it's gonna be a product. So the silver chloride should be on the other side. As precipitates are formed, right? So silver chloride precipitates when solutions of sodium chloride. So what is the chemical symbol for sodium chloride? NaCl. And it's a solution, so we need to use and then there's the other solution. NO3. So when we make a precipitant, it forms a solid. Right? So we're going to put an S, solid. And then think about pairing up, right? So just pairing up. So we have Na with who? Three. What is the charge on sodium? What is the charge on sodium? Charge. It's positive, one positive, right? What is the charge on nitrate? One negative, right? So they're balancing each other out perfectly. And then that's the same thing with silver. Silver is going to be a +1. And then the fluoride is going to be minus. They're going to balance each other out. So silver, 99.99% of the time, if there's no number, Roman numeral given to it, it's going to be a +1 charge. Okay. Okay. Reaction between acids and bases to form salts and water. So neutralization is basically when we are bringing an acid and a base together, and as a result of that, we're going to get the formation of water and salt. Okay. So this is just a generic representation of an acid. So HX plus N represents a metal, OH. Okay, so then as a result of that, we're going to get water because you're going to get the H plus reacting with the OH minus, the hydroxide, right, to form H2O. So let me give you an example. So if we have HCl, AQ, so that's hydrochloric acid reacting with sodium hydroxide. Okay, so what are going to be my products?
Would H two be one?
Still is gonna be one of them. And what's gonna be the other?
Salt and heat.
So imagine that. NaCl. So. Okay, so if we take a look at this in a little more detail, right? We know that in the case of an acid, hydrogen is acting as H plus. So that's going to be our plus ion. And it's going to react with the negative ion on the other compound, the hydroxide ion. So they're going to hook up, right? H2O. So in this case, the Cl is our negative ion, and the sodium is our positive ion, and they're going to hook up. Okay, so this is just a specialized what type of reaction? What was the ones where Swinger's reaction? Double replacement. Okay. I said Swinger. I call it a Swinger reaction because we're changing partners. You guys know what Swingers are?
Yup. I'm very educated. Don't ever go to a key party. 'Cause you find out the hard way, man. A key party. Gee, you're a child, so you shouldn't go. I didn't
Okay.
go, I just heard about it.
Where is that she goes to?
Shut the fuck up. No.
Okay, write the equation for the reaction between sulfuric acid and sodium aluminum hydroxide. Sorry, solid aluminum hydroxide. H2SO4, okay. And AQ. And solid aluminum hydroxide. Al. OH. How many am I going to need to balance it out? What is the charge on aluminum? What is the charge on aluminum? It's +3. Aluminum is always going to be +3. So how many hydroxides will I need to balance it out? And we know that it's a solid. Then that's going to make and what's that? Okay, Al, remember positive always goes first. Al, SO. Okay, what is the charge on aluminum? +3, and then sulfate is was -2, so then how many aluminum do I need to balance out the sulfate? How many sulfates do I need to balance out? I'll need 3 sulfates and 2 aluminum. Okay, so what is OHO? How many hydrogens are there?
Oh, it's water.
Okay, H2O. Okay, is it balanced? No. What do I need to do to balance it? So we can break them down into their quote, ionic parts. So we have our sulfate. They're pretty exciting. Okay, and we have aluminum. Then we can break it down to each pluses that are OHs. Okay. So we had 2 H pluses here. We have 1 here. 1 here. That together makes water. Right? And then over here we had 3. Okay, so what do I need to do to balance it? Put 2 in front of the- Okay, so that would give me my 2 aluminum. That would also give me 6. Okay. What about the sulfur? I mean, sulfate. So I need to put it right here. That would give me 6. Okay, so what do I need to put in front of the water? 6. Okay, questions? Concerns? Cash? Cash? Okay, so this is a summary of everything that I just taught you. That I've been teaching you for the whole semester. So let's take a quick, say 15-minute break. Okay, it says provide the correct IUPAC name for AL NO3 2 parentheses 3.
Are you on your actual web? Did you go to class? Yeah, click the first thing. There should only be one thing there. Well, I only got 2 left, so I think.
Okay, so what would be the name? Say aluminum. Put it down, write down the rules. I want you guys to write down your rules. Those rules, what are the rules? Do you ever use mono for an ionic compound? Okay, so we don't use mono for this. Nitrate. Aluminum nitrate.
Nitrate.
No, it's not nitrate either, because I clicked that one.
Nitrate?
That's wrong too.
You are just gonna nitrate.
Is silver a
I did that.
metal?
Okay.
I did
And we
nitrate
didn't
and
have silver as an
nitrate.
option, right?
It's not nitro.
Oh, you know what? It clicked the wrong one.
Nitrite, IT, right? Yeah. Okay, so it's NO2, so that means that it's 1 less than 8. It's IT, right? So it's nitrite. Okay, so provide the correct IUPAC name for AL HSO. Sulfate. Tell them this, but this was wrong. So it doesn't add up because the charge should be a -1, right? So there should be 3 of those, but it should be AL2, which should just be A. So that's the message. It says, write a balanced chemical equation based upon the following description. Solid chromium reacts with solid iodine to form solid chromium-3 iodide. Aye. That's gonna make. What did you say? CR. I3. Oh, Roman numeral? Put Roman numerals in there. Do you see Roman numerals here that I can put in there?
Oh,
So we don't put Roman numerals when we're writing the chemical formula. Roman numeral goes into the name, right? So it tells us, what does that 3 tell us? What does the Roman numeral say? It tells us that the chromium has a 3+ charge. So that means that how many iodine will I need to balance it out? Okay, and it's a solid. Is that correct? No? What's wrong?
It's supposed to be a 2 in front of the C.
A 2? In front of this CR? Okay. So you're saying I should have a 2 here? And 2 here. Okay, anything else is wrong with it? Okay, so there's only one iodine. What else do we know about iodine? Diatomic, so it should be written as what? 2. Okay, which means that I'm going to need to have a total of. Okay. No, check. It says, write a balanced chemical equation based upon the following description. Aqueous silver nitrate reacts with aqueous nickel 2 chloride to produce solid silver chloride and aqueous nickel 2 nitrate. So reactions are for H. Sure. Three. Why is it NO3? Because it's nitrate, ATE, NO3. Okay. And is that solid, liquid, gas, or aqueous? And that's reacting with? So nickel 2 chloride. So what is that? How many should I have? 2. Why are you guys whispering? God. Making it hard for me. Solid, liquid, gas, or aqueous? Aqueous. And that's gonna make. Solid, liquid, gas, or aqueous? So it's nickel 2 nitrate. So 2 nitrates. 2 nickels. Solid, liquid, gas, or aqueous? Okay, is it balanced?
Yes.
Okay. What do I need to add?
Coefficient.
Where? Is that right? So that would be 2 silver, 2 silver, 2 nitrates, 2 nitrates, 2 chlorides, 2 fluorides. That's good. What was the question? Okay, questions? No questions? Okay, you guys get it right? Okay, this is the last one. I'll let you guys do it. Show me your answers. Okay. Make it one more, right? Okay, so I'll let you guys do the last 3. So go ahead and do the last 3. And then submit your answers. Make it a 10. Four times. Here, I'll give you some more tips.
Okay,
Okay.
when you start explaining it, when you start writing it out, can you like start, oh wait, never mind. You're gonna do it on there?
Oh,
Never mind, ignore me.
okay, so let's start off with butane. I gave you guys what butane is. C
Subscript.
Four, subscript four.
H10,
H.
gas. So, right?
Okay, and we know that it's a gas. Okay, so we want to make sure that we're using subscripts here, because if you use the big numbers up here, those are coefficients. Okay, what's that? Okay, tell Jan.
Yeah.
Okay. So we also have oxygen gas. What do we know about oxygen gas? It's diatomic, so it's always going to be O subscript 2, and we know it's going to be a gas. And we're going to yield, what are we making? Carbon monoxide, so it's just
Yes.
and what else? Plus H2. Okay. Is it balanced?
No.
Okay, so let me write that down. You guys are a lot sharper than I am. It'll take me a minute to work the magic. So I know I have how many carbons?
One on the corner,
How many hydrogens?
you have 10, and then 2 on the corner. And then oxygen, you have 2, and then you have 2.
So if I wanted to get my carbons balanced, I'm gonna put a 4 here. So then that means I now have 4, 5 oxygens.
On the right side, right?
Okay. And if I want to get my hydrogens balanced, I need to put 5. So then that's going to give me 10 here. So that'll be a total of 9 oxygens. Okay, so since oxygen is diatomic, it can't really go into 9 with a whole number, right? It'll be 9 halves, right? So we're gonna have to use 9 halves here. And then we're gonna have to get rid of that half by multiplying it by what? We multiply it by 2, so we'll multiply this whole thing by 2. So, write the chemical equation up here, this red bar. So then I'll have 2 C4 H10 okay, now 2 times 9 halves, that's just going to be 9 plus 9 O2 and that's going to be 8 CO2 plus 10 H2O.
Said CO2. Did
Oh,
you
sorry, CO. my bad, CO. Okay. So let's just kind of confirm. So I have 2 times 4, that will be 8 carbons. I have 2 times 10, that will be 20 hydrogens. So that's 10 times 2 over here, that's 20. I have 18 oxygen, so I have 8 here and I have 10 here. 8 plus 8, 8 plus 10 is 18. So everything balances out. So then let's fix the equation down here.
Because it's becoming.
Let me speak out.
Okay, questions? Concerns? Cash,
No, it works. Works.
did that help?
Yeah.
So you weren't totally like way off?
But I would have never.
So what I recommend, if you guys go back to that very first week, those notes, right, that we went over. So we went over, actually we went over a problem just like this.
So it's always good to make sure it's balanced.
Okay, you guys got the last one, the last 2?
What?